Today's notes are on matrix operations. Some basic vocabulary for you is first, a matrix, also known as matrices, plural, is a rectangular arrangement of numbers in rows and columns. The dimension is the number of rows by the number of columns. For example, a 2 by 3 matrix. Entries are your numbers that you put in a matrix. We have several types of different unique matrices. The first is a row matrix, which is one row going across, or a column matrix, which is one column going up and down, or a square matrix, so 2 by 2 or 3 by 3. The identity matrix for a 2 by 2 is 1, 0, 0, 1, and for a 3 by 3 matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So your ones are going down on the diagonal. For example 1, it wants us to state the number of rows and columns in the given matrices. So the rows are going across your horizontal. So I have 2 rows going across, and I have 3 columns. 2 matrices are equal when they have the same amount of rows and columns and all of the corresponding entries are the same value. So for example 2, we want to tell whether or not the matrices are equal. So the first matrix we see has decimals in it, and the second one has fractions. So in order to tell if they're equal, let's change the fractions to decimals. So 5 divided by 2 will give us 2.5. Negative 1 divided by 5 gives us negative 0.2. So now we want to check. Top lefts are both 2.5. Top right are both negative 1. Bottom left, both negative 0.2. And bottom right are both 3. So we could say, yes, the matrices are equal. Looking at part B, I want to see if they're equal. And right away you can tell they're not because the top left on the first is 1 and the top left entry on the second matrix is 0. So because even 1 doesn't match up, the matrices are not equal. Let's look at the next page where we're going to add and subtract and multiply matrices. To add or subtract matrices, they must have the same dimension, and then you will add and subtract the corresponding entries. So for part A, we have a 1 by 3 matrice, and they're both the same dimension, so I can add them together. I'm going to add the corresponding entries, and my answer will also be a matrix. So the first one, I would add 0 and 1. Then I'm going to add 4 and negative 9, and 3 and 8. My answer matrix are the simplified rows, so 1, negative 5, and 11. For B, I'm going to do the same thing. I'm going to combine entries in the same spot on their matrix. So I have 3 minus 2, so notice that we are subtracting this time. The top right corner is going to be 3 minus 0. Bottom left is going to be 9 minus negative 3. And bottom right, negative 5 minus 5. So if I simplify this, combine those terms, I get 1, 3, 12, and negative 10. C also asks us to subtract, however, this is not possible because they have different dimensions. All right, the next thing we're going to look at is example 4, which is going to talk about multiplying a matrix. In order to multiply a matrix by a scalar, which is a single value, you multiply each entry in the matrix by that scalar. This process is called scalar multiplication. So for my answer, I would have 6 times 2, which is 12, 6 times negative 3, which is negative 18, 6 times 8, which is 48, and 6 times 4, which is 24. And again, my answer is going to be written as a matrix. Example 4b has 2 parts to it. I first must simplify using the multiplication, the negative 1 times that first matrix, which means that I'm now going to have negative 4, positive 7. You don't need to put the plus there. Negative 3, negative 3, negative 2, and 9. This is now the matrix that is being added to the 3, 6, 9, negative 8, 1, and negative 4. So if I look at simplifying this, I'm going to add entries that are in the same spot on the matrix. And I'm going to simplify to get negative 1, 13, 6, negative 11, negative 1, and 5. This matrix would be my final answer. Please try example 4 on your own. Notice that there are parentheses, so you'll want to simplify those matrices inside the parentheses first before combining it with the matrix on the end. Last thing we're going to look at is example 5, which is going to show us how to solve the matrix equation for x and y. We are going to talk about this tomorrow in class as well, but we're going to get it started today. So the first thing that I'm going to do is simplify inside the parentheses. So if I'm adding common entries, I would get 3x plus 4 in the top left, negative 1 plus 1 in the top right, 8 plus negative 2 in the bottom left, and 5 plus negative y in the bottom right. And it's still equal to the same thing. And I'm going to simplify the terms that I can. So 3x plus 4 I cannot simplify, but I can simplify the bottom left to be 6, the top right to be 0, and the bottom right is going to become 5 minus y. Alright, now I can perform my scalar multiplication and multiply the 2 by all of the entries. When you multiply it by the first entry, make sure that you're multiplying both of the parts by 2. So this becomes 6x plus 8, 0, 12, and then again multiply 2 by both parts, 10 minus 2y. And this is still equal to the 26, 0, 12, and 8. Our last step for solving is going to be to set equal the entries that have variables in them. So notice that both top rights are 0, both top or bottom lefts are 12. This means that the matrices are going to be equal. So I can set 6x plus 8 equal to its corresponding entry, which is 26, and I can solve. So I would subtract 8 from both sides to get 6x equals 18, and I would divide both sides by 6 to find x equals 3. Using that same logic, see if you can find what y would be equal to. We will discuss it tomorrow in class.